Hello. So what we're going to be doing is we're going to be multiplying these two factors, and we're going to get our answer. Now, there's a couple different ways we can multiply this. I was really surprised by how many people said they liked the distributive method, where I distribute this one to here, and this one to here, and then this one to here, and this one to here. That is okay method, but a lot of students make mistakes when we start getting more than two factors, or if we get larger factors. We call these factors because we're multiplying them together. So if we get larger ones, it becomes very, very challenging to use the distributive method. I like the area model, plus it will really help us next chapter. So we're going to be multiplying from here on out using the area model. And then what we do is we draw a rectangle. Here's our rectangle. And we're going to write one of the factors on top here and one factor on the side. It doesn't matter which one we do. So I'm going to go ahead and put x minus 2 here. Now, the mistake that most students make is they forget that the negative or the minus sign goes with the 2. This is like positive x and negative 2. Positive x, negative 2. Here we have a positive x and a negative 3. So we got to make sure that the minus sign or the negative sign stays with the number that it's in front of. We did that. Now we can go ahead and multiply. X times x gives us an x squared. X times negative 2 gives us a negative 2x. X times negative 3 gives us a negative 3x. And negative 2 times negative 3 gives us a positive 6, because a negative times a negative will always give us a positive. Now, just like the warm-up, we talked about like terms. Do we see any like terms here? Yes, we do. Right here are some like terms. That's one of the main reasons I like the area model, because most of the time, almost every single time, our like terms will end up diagonal each other. And we'll be able to see a negative 2x and a negative 3x. Those are like terms, so we can combine them or we can add them together. What do we have left over? Well, this has no like terms and this has no like terms, so that's just going to be part of our answer. First, we have our x squared. We have a negative 2x and a negative 3x. When I add those together, I get a negative 5x, and I have a positive 6. Here is our solution, x squared minus 5x plus 6. So when I multiply x minus 2 times x minus 3, I get x squared minus 5x plus 6. And this is a diagram using the area model for it. I'm going to show you two more problems. What I want you to do is I just want you to watch these problems. I don't want you to write anything down. I don't want you to do anything. I just want you to watch through these, how we do them, so that you can understand it, and then I'll give you instructions after those other three problems. So I'm going to pause the video real quick, and we're going to get to problem number 2. We're back. Problem number 2. Here we go. We have one factor and another factor. This one's slightly different because it's the first time we have a number in front of our x here that we're multiplying. But we still do it the exact same way. We're going to use our area model. So let's draw our rectangle. And it doesn't matter which factor we put on the top or the bottom. I'm going to just go ahead and put this one right here, 2x minus 2 on the top. So my first little spot goes 2x. And my negative 2 goes over in this box. And then we have our other factor, x plus 1. That means our x goes here, and we have an x and a positive 1. So we have an x, a positive x, and a positive 1. We don't need to write plus 1 because we know 1 is just positive if we don't have anything next to it. Now let's multiply. So I have 2x times x. Well, technically, if you think about this, this is actually like a 1x, but the 1 just isn't there. So what I do is I multiply 2 times 1, which gives me 2. Next, I multiply x times x, which gives me x squared. So when I multiply 2x times x, I'm left with 2x squared. Next, I'm going to multiply my negative 2 and my positive 1x, or x. Negative 2 times 1 is negative 2. And there's no x here, so I just am left with 1x. 2x times 1. Well, anything times 1, 2 times 1 is 2. And there's no x, so that x just comes down. And last but not least, negative 2 times 1 is negative 2. That's a funky 2. Negative 2. Okay. Let's combine some like terms here. Let's see. Ooh, I have a negative 2x and a positive 2x. Those are my like terms because they have the same variable with the same exponent of 1. Let's write our answer. 2x squared has no common terms. I have a negative 2x and a positive 2x. Negative 2 and positive 2, those cancel each other out, don't they? Cool. And a minus 2. Minus 2. This is my answer. This one's a little bit different because our two like terms canceled out, so we just don't draw them in there. We don't write them in our answer. So we have negative, or 2x squared minus 2. And I multiplied my factor 2x minus 2 times x plus 1, giving me my solution of 2x squared minus 2. Let's look at number 3 now. Remember, you're not writing anything, you're just watching and seeing how this works. Problem number 3 looks a little different. We have x minus 2 quantity squared. And what this little squared means, it means everything inside these parentheses times itself. Before we get that problem, let me show you what this means. 4 to the second power. Now I know what you're thinking. You're thinking, oh, well, that's 16. But why is it 16? What does this actually mean? This means 4 times 4, doesn't it? 4 to the second power is 4 times itself. What if I put parentheses in it? Well, it's still whatever in these parentheses, the squared means times itself. So that would be like this. 4 times 4, which gives us 16. Now I want you to take this concept and apply it to here. What does this actually mean? It means x minus 2 quantity squared. So it means everything inside these parentheses times itself. Well, I went off the screen there. So we get x minus 2 times x minus 2. That's what this actually means. Let's get rid of our example here. Now we know how to do this. In fact, we just did 2 of them. So let's do another one. We're going to use the area model to multiply these 2 factors. I draw my rectangle. In fact, you know what? This actually isn't a rectangle. This is called a square. How do I know it's a square? Because this side will be the same as this side, which means that this has to be a square. In fact, that's why they call it x minus 2 quantity squared, because it creates a square. So, by the way, if you don't think that's cool, sorry, I do. X minus 2 and x minus 2, my negatives come with my 2's and negatives with the 2's. Now we can really see that this is a square because I have the same length here. This side of the rectangle is x minus 2 and this side is x minus 2. So we have a square here. And we can go ahead and multiply. X times x gives us the wrong marker. X times x gives us x squared. Negative 2 times x gives us negative 2x. And x times negative 2 gives us negative 2x. And negative 2 times negative 2 gives us a positive 4. We can combine our like terms, which are the diagonals here, a negative 2x and a negative 2x. I can combine those because they are like terms, leaving me with x squared. Negative 2x and a negative 2x do not cancel out. That's like saying, hey, you owe someone $2 and you owe someone $2, so technically you owe $4. So negative 2x and a negative 2x gives us a negative 4x plus 4. This is my answer. Just to recap, this x minus 2 quantity squared just means x minus 2 times itself, so x minus 2, x minus 2. We set up our factors, one here and one here. We multiply to fill in our rectangle, or in this case, a square. And then we add to combine our like terms. And when we do that, we get x squared minus 4x plus 4. What I would like you guys to do now is I would like you to please either stop this video or pause this video and go back and watch it again. But this time, I would like you to please copy down what you're seeing. Now that you've watched it once, I would like you to go back, watch it again, and on a blank piece of paper, copy down problems numbers 1, 2, and 3. You've watched it and your brain understands what's coming next now. What you need to do is to really sink it into your brain. You need to go ahead and put pen to paper and write it down. So please do that right now, and then let's do the next couple problems. All right.